Click for IV Biology. We're studying the communities of ecosystems and moving on now to look at predator-prey interactions. There's a blank of this presentation, a blank PDF of this presentation in the description. You can annotate that with your own notes. There's 10 questions down there with answers. And also there's an AI prompt that you can cut and paste into a chatbot to individualize your own learning. So predators and prey. So again, we're using local examples to where I am, and our local top predator is the tiger. Panthera tigris corbii is known as our tiger. Slightly smaller and slightly darker. So in the Malaysian and Thai forests, this slightly smaller tiger, slightly darker, but with all the adaptations of a top predator. And we can see those illustrated physiologically, if nothing else, in the skull structure, where we have the canines here, the piercing canines, upper and lower jaw, and here in the premolar molar region, those teeth there are adapted into almost like scissor-like action of the carnassial teeth for slicing flesh. So that's a physiological adaptations. And of course, there's also binocular vision for judging distances and looking at movement. And that's before we get into the muscularity and skeletal structure of the skeleton. Their behavior, of course, is this predatory stalking action. And what they're stalking at the top end of the prey in the Thai forests are animals like this. These wild cattle here are called galah. And of course, there are elephants. But these two species would be a top attempt by any tiger to carry out predation. These herbivores are armed with considerable modes of resisting any attack from such a predator. The galahs are famously aggressive animals, and elephants in their herds are able to, and their size of course, are able to protect each other very, very effectively. The herbivores, they also have their own behavioral and physiological adaptations. Behavioral, I've already mentioned in the aggressive behavior of these cattle here, and the elephants with their altruistic herding behavior is well known, and they too can be extremely aggressive if annoyed. They are adapted to their herbivore role by having these grinding teeth at the back with their flattened ridges on, grinding molars at the back here. They have this diastema, this gap here, that is a way in which, as they eat the grass, and even that is interesting adaptation, that they have teeth on the lower, incisors on the lower jaw, but on the top jaw there's a kind of a pad there. And so both the galah and the elephant are famously for eating long grasses. Short grasses they would leave to goats in this part of the world. And here's an example, is a picture of their teeth here, which shows the grinding ridges for the breaking down of the plant material that you can see clearly in the images here. So they each have their own physiological and behavioral adaptations to their mode of feeding, and indeed, of course, their mode of defense. The interaction of predators and prey, it was realized, often have a cyclic pattern with each other, which in which their populations behave in what is called a density-dependent manner. The most famous story comes from about 1935, from two ecologists working in Canada, and they were able to take the records from the Hudson Bay area. And what I'm referring to there is there was a company that worked here, which was called the Hudson Bay Trading Company. And the Hudson Bay Trading Company would receive animal pelts from hunters in the wilds of Canada, and they would take those and sell them on, but they would keep records of those. And so they had records of the hare pelts that they had, and they had records of the lynx pelts that the hunters would return. Now, the argument is that the more hares are present, the more that the hunters will find. And the more lynx which are present, the more the hunters find. So it's a kind of sampling technique through their hunting. So the two ecologists in this were was Lotka and Volterra. I think I've spelled that correctly. Perhaps only one T here. Volterra. And what they did was they took the trading companies' records of their trading and they plotted them on a graph, and they found this pattern here. And you can see that this goes from 1845 through to the early 20th century, when they actually began to plot the data together. And so what we can see is that in green is the hare and in red is the lynx. And notice how there's this oscillating pattern of increasing and decreasing for both hare and lynx, but they are not synchronized. In fact, they're asynchronous. So let's take this region here as an example. So with many hares in the population in about 18, I think that says 65, the population of hares increase. And then what happens is that with more hares available, the lynx are more successful in their predation, and so they are then able to survive better, and so their numbers begin to increase here. But of course, with more lynx, the number of hares will then decrease. And of course, once the hare population decreases, then the lynx population is going to suffer. So then the lynx population comes down. And so there's this cycling of up, down between the hare population and the lynx as they interact with each other in what is described as a negative feedback manner. And it's all regulated around a so-called fixed point, which of course in our case is the carrying capacity of the habitat. Now the carrying capacity is determined by the presence of the number of hare and at the number of lynx at any particular time, and any disturbance through predation will then be countered by a reduction in the population of the prey. But it regulates around this kind of fixed point, which is the carrying capacity of the area. So this is one of the early ecological studies of populations, and students should be aware that of course there's more to this than just the numbers, because the hares which are successful in evading the lynx must have characteristics or behavior which is advantageous, and so we're starting to think now in evolutionary terms, that the environmental resistance doesn't just reduce the number of individuals, it also selects individuals which are better suited to survival in the area, be that the lynx or be that the hare. And so we're starting to see the role of evolution in ecology, and indeed there is the phrase that ecology is actually evolution in action, which is a very useful way to think about ecology. So we'll go on and look at other features of the interaction of our community. There's the subscription button for the channel and the playlist for population and communities.